Yeah, see the problem. An array contains both positive and negative numbers in random order. An array contains both positive and negative numbers in random order. Rearrange the array so that positive and negative numbers are placed alternatively. So if the array is like this, you have to arrange like this. If you want, you can check. So first positive, next negative. Positive, negative. Positive, negative. You have to arrange like this one. Positive, positive, positive. Because negatives are over. If negatives are over, if one person is over, left out people, lastly you can write. Similar way here. Similar way here. This is the input. See the output. Positive, negative. Positive, negative. Negative, negative. So if at all positives are over, keep negatives. Some people are asking, sir, which one I have to start, sir? If you want, you can start a positive, or if you want, you can start negative. It's up to you. Right? See, a number of positive and negative numbers need not be equal. If there are more positive numbers, keep at the end. If there are more negative numbers, keep at the end. Rearrange the array elements so that positive and negative numbers are placed alternatively. So if you want, you can start positive. Okay, I will write that also. Start with positive. Start with positive. Because I started. If you want, you can start with negative also. Let's give this condition also. Start with positive. I hope this is a very simple. So let's see how you are going to manage it. There is a one array containing both positive and negative numbers in random order. Arrange the arrays so that positive numbers, negative numbers will appear alternatively. Suppose, right? Suppose a number of positive numbers, right? Positive numbers, negative number need not be equal. If there are more positive numbers, they appear at the end. If there are more negative numbers, they are also appear to be at the end. I given some examples also. Can you see these examples? Can you see examples? This is the given array. This is the given array. If you see the output, see positive, negative, positive, negative, positive, negative, positive, positive, positive. See, if at all positives are more, they will be at the end. If you see the one more input, see this one. This is the input given. Second input given this. So you see the output. Positive, negative, positive, negative, negative, negative. I hope problem is clear. Let me give answer for this. Yesterday I already explained the problem. Now let me explain the answer. So this is the array. To explain this problem, I took one array. Right? So this is the array. So array index is starting from 0 to 12, which contain both positive and negative. Both are there. I have to convert this array into positive, negative, positive, negative, positive, negative like that, or negative, positive, negative, positive like that. How I am going to do? Let's see once. Remember, I is the index initially -1. J is the index initially 0. So J is the index initially 0. I is index -1. Remember everyone. J want greater. If greater, J will. If at all, see this one. A of J, array name is A. Assume that this array name is A. If A of J is greater, because J want greater. If A of J is greater, happily J will move. If not, J will stop. Remember, I want smaller, J want bigger. I want smaller person, means I want the negative person. J want the positive person. Right? See what is going on. So J will ask, J0, A of 0. J will ask, hello, the number whatever there in the 0 is place. Are you positive? No. Whenever J will say J positive, J will happily move. If J is not positive, J will stop. Then I will inform to I will increment by 1. Then swap A of I, A of J. So I think he will swap himself. After swapping is over, as usual, careful everyone, as usual, J will increment by 1. Again, J will ask, are you greater? No. Then immediately J will inform to I, you also increment 1 because I see the negative. Whenever negative will come, I will increment by 1. J will always increment by 1. Whenever negative, I will increment by 1. Then you have to swap A of I, A of J. I will write the program also. Please careful. Right? Next one. So, are you greater? J is asking, are you positive? No. Then I will increment by 1, swap itself. There is no use. right? So I think I will become 1, j will become, j also becomes 1. J will always increase. After swapping is over, again j will increment by 1. J again will ask, are you positive? No. Then it will increment by 1. So j is always incrementing. So I will also, whenever j got the negative, right, j will inform to I will also increment. Then swap a of I, a of j. So there is no use. Next one, as usual, I will increment by 1. So j will increment by 1. J will increment by 1. J will ask, are you greater? Yes. If at all greater, J don't inform to I. J will go happily. Right? Same. Because if I am doing here, no need to do 2 times. Next one. Are you greater? Yes. Means positive? Yes. Are you positive? No. Whenever it is not positive, inform to I, increment I. I will increment. Then swap A of I, A of J. I value 3. J value 5. Swap them. Minus 100 here, minus 100 here, right? 80 here, right? After swapping is over, as usual, J will go. Are you positive? Yes, no problem. Are you positive? Yes, no problem. Are you positive? No, stop it. Whenever he stopped, I will increment by swap A of I, A of J, swap it. So it became minus 88, he became 90. Right? He became 90. Remember, this entire story is going on in for one for loop or one while loop. Until J crosses boundary. J is the one who will always go in the forward direction. I'm just writing rough diagram. While some condition. While, right? J less than N. Because 0 onwards starting, right? N minus 1. N minus 1 onwards, the loop is going on. Initially, I is minus 1, j is 0. This loop is going on. Whenever this loop is going on, what are you doing? You are check one condition. A of j is greater or less. If it is less, it is less than 0. Because A of j want greater, but less than 0, then you have to do inside one thing. I is equal to I plus 1 swap. A of I, A of j. That's it. This is the thing which is going on. Right? This is the thing which is going on. Then what about, you may say that, what about j? J will always increment by 1. If smaller, I will increment. If not smaller, j will always increment. So this is the thing which is going on. Same thing. Whatever I done, I written the rough code also. Right? After swapping is over, as usual. Right? J will go further. J will ask, are you positive? No. Then increment by 1, 5. I and j swap it. So 40 minus 44 and 8. Next one, as usual, same. J will increment. Are you positive? No. So I will increment by 1. Whenever not positive, I will increment by 1, swap it. I value 6. So it will become minus 68. It will become 200. What is going on? Within a few minutes, you will get. J is equal to j plus 1. Are you positive? Yes. Are you positive? Yes. J crosses boundary. So out of the for loop or out of the while loop. Out of the for loop or out of the while loop. Simply execute this code. It doesn't matter which programming language. Some syntax I written. I initially minus 1, j initially 0. Remember, I meant for negative people. J meant for positive. Right? J meant for positive. See this one. If A of j became positive, no work is there because j want positive. If it is a positive, no work. J is equal to j plus 1. If it is negative, then inform to I, swap it. This is the loop which is going on. Some people are asking, what is the use of these things, sir? What exactly you done? Remember, in computer science, this is one of the famous algorithm. In computer science, it is one of the famous algorithm. This algorithm name is called partition algorithm. What this partition will do is, if you want, you can verify. See this one. It's a minus 55, minus 65, minus 75, minus 100, minus 88, minus 44. Observe properly. minus 68, right? So if you observe clearly, these all are positive, these all are negative. What the partition algorithm will do is, it will keep all negative numbers one side, it will keep all positive numbers one side. That is the reason it is called partition algorithm. This time complexity is one for loop or one while loop, right? Order of n time. By taking one scan, I made all positives one side, all negatives one side. Right? This is the code for the partition algorithm. This code is called partition algorithm. Very simple. I meant, right? I is meant for negative people. J meant for positive people. Right? Whenever positive, J don't have any one. J is equal to J plus one. Whenever negative, then some work is there. How I is equal to I plus one, swap A of I, A of J. This algorithm is called partition algorithm. Purpose is keeping all the negatives one side, all positives one side. One loop is required. One loop is required, which is order of n. I hope everyone is comfortable till now. Right? Now, if you comfortable, all positives one side, all negatives one side, you done. Now the same code I written. See, same code I written in the form of a right, Python program. So one for loop is going on, this one, I is equal to minus 1, j in the range of n, right? Range n means 0 to n minus 1. That is the meaning of range n. 0 to n minus 1, this loop is going on. J will start from 0 to n minus 1, I is equal to minus 1. Now see, whenever this for loop is going on, this code will execute. Whenever this for loop is going on, this code will execute. So if condition is one, if condition true, this code will execute. If condition fail, as usual, right? While loop is going on. Same story I written in the Python programming language. I'm not done anything. Now observe clearly. So I'm writing the output. See everyone, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Assume that 11 people. At the end of the partition algorithm, this is called partition algorithm. This story, whatever I written, right? This story. If you want, I will use another color. If you want, I will use another color. This story is called partition algorithm until here. It is called partition algorithm in Python programming language. Just know the Python programming language syntax. Nothing is there. Right? Now, after completion of the partition algorithm, you are able to see negatives one side, positives one side. Let us assume that some numbers, minus 80, minus 90, minus 60, minus 40, minus 50, right? Minus 30. Let me write now. So 10, 20, 30, 40, 50, 60. After Partition algorithm, this is the behavior. And one more thing is, listen, after partition algorithm is over, one more thing if you observe, observe clearly, one more thing if you observe, wherever I is there at the end of the partition algorithm, I is somewhere else. See this one, I is 6. Careful, I is 6. Remember, if I is 6 means last negative number is this and 6th place. Last negative number is 6th place. I plus 1 onwards positive there. At the end of the partition algorithm, I is there 6th place means 7th place onwards positive numbers are there. Right? So I will do one small story here. At the end of the story, right? So what is the I here? In this problem, I is going to be 5. Because I plus 1 onwards, positive numbers are there. Remember? So I am taking now two variables. Right? Positive is equal to, see one. Positive is equal to I plus 1. Negative is equal to initial person. So I am taking two variables. Negative is this. Positive is this. At the end of the partition, negative is this, positive is this. Right? Now you have to do one small story. Right? What is that one? Positive less than, right? If you want to connect negative. Positive, negative. So negative is 0, positive is 5. And the length of this array size is n. Is n. Length of the array size is n. Negative is 0, positive is n. Now see what is going on. Right? Until array is not over, continue this. What is that? Very simple. See this one, very simple. Negative place, keep the positive. Positive place, keep negative. You have to swap. You have to swap. So let me use another color. You have to swap. So negative place, right? Wherever negative is pointing, wherever positive is pointing, so swap the data. See this one. I think here became minus 30, right? So I think positive means here. Positive is here. Positive is equal to, right, I plus 1. Right? Positive here. Swap it. So here it is going to be, 10. Here it is going to be minus 80. Right? After swapping is over, see this one. This is called swap code in the Python. After swapping is over, remember, positive will increment by 1, negative will increment by 2. Negative here, negative, next negative here. Positive will increment by 1. Afterwards, again swap. So it is going to be 20. It is going to be, right, I think minus 80, I think minus 60. Again, same story. Negative will increment by 2. Positive will increment by 1. Swap it. It is a 30. It is a minus 50. As usual, as usual. Negative increment by 2. Positive will increment by 1. Swap it. Right? Swap it. I think what is the positive here? 40. So I think this number, whoever is there, I think here minus 80, there's some number, right? Whoever there here, whoever there. Let us enter minus 80. 40 here, minus 80 here. Some negative came. Right? As usual, negative will increment by 2, positive will increment by 1. Swap it. So minus 50 maybe, minus 50 maybe. So this 50 will go here, this 50 will be here, as usual. So negative will increment by 2, positive will increment by 1. Whenever positive crosses the boundary, see this one. If it is crosses boundary, come outside. When you come outside, see the output. 10 minus 90, 20 minus 40, 30 minus 30, 40 minus 60, 50 minus 80, right? Minus 80. Next one. Yeah, this is a minus 80. Lastly, 60. Something like that. What I mean to say is, at the end of this algorithm, you are able to see positive, negative, positive, negative, positive, negative, like that. This loop will take care about that. This loop will take care about this. If anyone having small doubt, see this code one time. You will get the clarity. Little doubt also there. You can see this particular code, you will get the clarity. So finally I given some rough diagram. Code also I written. So the answer for this problem, first step, I am writing the pseudo code. First step, apply partition. Pseudo code is apply partition algorithm, means negatives one side, positives one side. Afterwards, swap these two people. Negative will increment by 2, positive will increment by 1. That's it. Then you will get, after partition algorithm is over, right? Do this one also. So remember, one loop for this, n time here, totally 2n time, which is nothing but order of n time. What about space? I am not taking anything space. Within the array I adjusted. So extra space is order of 1. This is the answer for this. I hope you got it. Partition first. Partition algorithm also I written. This is a partition algorithm. Next one is right. So positive person will be there. P will be there first to positive place. Negative will be there first to negative place. Right? First to negative place, negative is there. First to positive place, positive is there. Swap them. Afterwards, negative will increment always by 2. Positive will always increment by 1. Do that until this condition is failed. Then you will get it. There are 2-step procedure. This algorithm contains 2-step procedure. First step, partition, means positive one side, negative one side. Positive one side, negative one side. Right? First to negative, followed by positive. That is the thing what the partition algorithm will do. Followed by negative, positive, spare. But increment negative by 2, right? And increment positive by 1. At the end of this, you will see positive, negative, positive, negative, or negative, positive, negative, positive. That's it. This is the code for this. Roughly, I written the code also. Please take care. Please take care of this particular program. I hope you got it. If anyone having small doubt, see the code. That is the reason I written the code also. Little doubt also there, you can see the code. Right? So this is the partition algorithm. I think C programming language I written. C programming language I written. In the Python language, brackets are not there. In the C programming language, brackets are there. You may be clear. In the Python language, everything is space only. Space only. Everything in the Python language, space only. Right? This is the space. So for, right, it is a for code. Space only, right? If it is a for code, inside for it will be there. Because of lack of bracket inside, you have to give space here. Right? And one more thing is, right? This is the code of not for loop. Outside for loop means this function code. See the space, exact space you see. Right? This code is for the for loop purpose. This code is for the function purpose. Same way. This code for while loop purpose. Whenever this code is going and see some, whenever while loop is going, see the space. See the space. Right? Perfect. Everyone know, if you know Python, you know the power of this particular gaps and all. Python language, everything is based on, right, space. But in C language, you have to keep brackets. Here you have to keep the space. Other than this, nothing there. So if you want, you can see this one. This came little outer. It came little outer. This is for this. Right? These people came inside. This is inside story. So like that. So it is a partition algorithm, which will take n time. This is for positive, negative, positive, negative. This is one more n time. Total 2n. Total 2n, order of n time, order of one space. So that is the answer for this. I hope everyone got it. Yeah, perfect. Small doubt also there. You can ask. You can post in the comment section. Right? We are going to help you. There may be so many algorithms. It is one of the best algorithm for this. There are so many algorithms. It is one of the best algorithms.